Hello, I'm David Washington, the CIO of XZY University. Today, I want to propose a new software system that will equip our university in making more informed decisions through data analytics. We'll look at our strategic plan and goals, benefits from creating a system or using a system like this, an overview of the product that we would use and how much it would cost, our security risk and any security concerns, how we would implement this product or project, and a couple of examples of some of the results we can get from implementing a product like this. Our strategic plan or our goal is to utilize innovative data analytics, machine learning, and predictive analysis to more accurately predict and analyze information. Um, we want to enhance the student experience, understand how student aid is used and its effectiveness, predict enrollment and how campaigns affect new enrollees, marketing program effectiveness, and gain insights on giving and donations. Our university is broken down into six major component departments. Individually, each department will benefit from the proper implementation of data analytics. However, the data collected for each individual department uh, can be viewed and analyzed across all departments. There are several cross correlations between departments, such as how financial aid impacts student retention, how marketing campaigns impact admissions. There are probably several more cross correlations that also are waiting to be discovered. Let's look at each department and on it, and we'll see a couple of those cross correlations. For the for financial aid department, we'll be able to analyze students by demographics and see what types of grants and scholarships and loans they get. Um, we'll be able to, for admissions, we'll be able to better predict what our next enrollment goals will be. Um, we'll be able to see if our marketing campaigns help in our admissions and identify the campaigns that had the biggest impact on enrollment. And we can look at different geographical areas and target those areas for maybe marketing campaigns and which areas are generate the most admissions. For marketing, we can look at which campaigns have the most effect and impact on different things like our admissions, which areas to target, and for student life, we can see which events uh, the students like the most, and asking and collecting data on how that impacted the students and how effective it was for them. And for registration and retention, we can identify potential classes that may be tough for some students and why those classes are a problem for them, and if if by cross correlating financial aid and looking at demographics, um, seeing if those students are a little behind or what the problem is, maybe can be brought to light through data, and we can make adjustments, maybe provide personalized assistance, or maybe even modify the course some. Um, and donations and giving, we can see how which events produce the most money, which ones the alumni liked the most, and how effective they were. For this proposal, I'd like to propose um, using Microsoft Azure and their data analytics. Um, just saying data analytics, that's not really a package name. It's a bunch of products that working together can give you data analytics. Um, Based on a small university or a smaller university, these products can fit the bill and do a wonderful job. However, if I was going to implement this statewide, I would use a couple of more enterprise worthy or enterprise systems or products in this mix. And of course, it would cost a lot more. But for the most part, for 8,000 students, this should work very well. Um, and however, this is just the software. You really need to look at hiring a good data analyst and a good database administrator, or both. You can buy all the software you want, but not having the people that have the knowledge to implement it can be a serious problem. So the components that make up a data analytical system using Microsoft Azure uh, for extracting, transforming, and loading from those data silos of each department, I would use Azure Data Factory, and this will um, move data from those individual data stores into a either a staging database or uh, directly into the data warehouse, and you are charged for each run or process or workflow. And then I would use Azure Analysis Services for the data warehouse, and I would also allocate some space to store files and logs and backups using Azure Blob Storage. And really, you really can't do anything until you uh, use the Entra ID, which is formerly the Azure Active Directory, to set up user identification and security. Um, that loading or staging database would be just a cloud-based SQL server using Azure SQL DB for creating dashboards and reports and graphs and all that good stuff. Use Power BI, and once you get all this stuff running great and in place, um, go ahead and use Azure machine learning, and from that data that you collect, you can train your models and start doing predictive analysis. Each department may contain its own data silos. However, data from these departments can be extracted, transformed, and loaded, which we call ETL, into data marts. So it doesn't affect the existing data that are in each department. It's going to pull data from those departments. Um, they can be in all kinds of different formats. We might Maybe the department can only export Excel spreadsheets or JSON, or um, they will allow us to pull from those departments, which would be the better choice. Um, the data can be extracted into a staging database, or we can have a workflow that actually works out really good, and we can just put it right into the data warehouse from the department. Um, the data is inserted into the data warehouse, and it's stored in Azure SQL or Azure Synapse. If it was a very large system, I would recommend using Azure Synapse. Of course, that's a big chunk of money. Um, Once the data is in the data warehouse, uh, we can use Power BI to create a dashboard, and we can also use it to generate reports and um, graphs. And all those can be automated inside Power BI, and you can include the reports and the graphs and all that stuff as part of your dashboard. Now, once all of this is working, and you know that you've validated that the data that you're pulling and aggregating is looking really good, that's when you want to. The last thing you want to do is implement machine learning, because machine learning is going to be a wash if your data is not correct. And also, you kind of need quite a bit of data to train your models. But at the end, we're going to implement machine learning to perform predictive analysis, and we're going to train uh, those models on the data warehouse, on the data stored in the data warehouse. Uh, I'm a data guy by heart, as you can tell by my gray hair. I've been around a while. I was the lead DBA for the U.S. Office of Personnel Management, their data center, which is located right down the street from our Macon campus on Eisenhower. Um, Believe it or not, that little building has a lot of very large systems that are used by just about every agency in the whole federal government. Uh, I worked there for 20 years, about over 20 years, and I worked for the Air Force for 13 years, and then the Navy for 5 years. Um, Through that time, I've done just about everything you can think of, but my favorite thing is databases. Um, and I've developed several very large transactional databases, but I've also developed quite a bit of analytical databases. Um, so most analytical databases use something like a star schema or a snowflake design. This I actually implemented a working prototype for this, um, just to see what our university could do, what benefits we could get from a system like this. Um, and some of the tables would look like they are in this data marts table. Um, from looking at this, you would have, like, for a registration, you'd have different ways to look at a registration data, from different dimensions. Like, each term, you can accumulate or aggregate data and look at it on a term basis, or you can look at it on a student basis. Of course, the actually in the registration, you'd also have another dimension of date. Then in the marketing, you'd have a dimension of date, but you can also add other dimensions into the marketing campaign too, or the marketing transactions. But anyway, um, this is called OLAP, or Online Analytical Processing. Uh, and you would, if you were using the Azure SQL um, analysis services, uh, you would develop cubes and all kinds of different things that you can use to analyze this data from just every type of angle you can think of. Some of the risk, you're always going to have risk, and you're going to have um, potential security problems. Most of the security problems are self-inflicted, in my opinion, especially when you're working with systems like Azure or AWS or Oracle Online. Most of these cloud-based systems provide every type of security you can ever imagine. The problem is a lot of people don't know how to use it or implement it, And sometimes they get lazy and they get a system working and they're like, okay, let's don't do anything else. Let's just get it out the door. Well, that's a very dangerous thing. Um, this is why you hire people that are professionals that know what they're doing, and you have a team of people that can go back and analyze security. You have a security team, a data team. You need to logically break up everything. Um, some of the problems we can see are weak password policies, um, no multi-factor authentication, um, having a big storage blob out there that's just where we can pile our files into and don't and some of these files may contain private information and they're not encrypted and they're just out there in the wild. That can be dangerous. Um, using basic authentication on a database like password instead of using Active Directory logins through the Enter ID. That's very dangerous. Um, good thing to use that a lot of people don't use. I don't know why. Is Microsoft Defender for cloud. This can, if you set it up right, you can actually monitor data and you can monitor um, different vectors of attack, as well as malware and viruses. And you can set that up to alert individuals or teams. Um, built-in logging, or when you create some of these applications, it's good to make sure you have several different levels of logging and different types of logging. If it's a very large system, you probably want to have some type of way to have like a normal day's worth of logging for the application. And in the event that you start having problems or you think there might be a security problems, you can increase that. So you want to have some way you can, because logging can become a nightmare. It can actually, uh, in most cases, it will exceed the data that you collect. Um, your logging will be a lot more than the data that you actually collect. And some of it's just kind of throwaway data for the most part, but um, not having it can be a serious problem. Um, sometimes you don't recognize problems until a few days later. So by having a good set of logging rules, you can go back and start replaying some of those issues. And of course, you want to set up alerts. The sooner you can tackle a problem, the better, or shut down a system or prevent somebody from coming in, the better you're going to be. Implementing a system like this is actually not that hard. It takes a little bit of time, but it doesn't impact existing data. So um, it won't impact any current production tables or any current systems. The data is pulled from those systems or the data is pushed onto our blob site and then we pull it from there. Um, the best thing I would suggest to do, like I said before, is to get um, like phase two, phase three, and phase four working perfectly before ever implementing phase five. Um, some of these phases can be done in parallel, but like really, um, most of the time, most of these are a step by step. Really, it's like you want to get your data if you need to into a staging area, and then you want to cleanse that data, and then you're going to pull that data using the workflows and Data Factory. Then Data Factory is going to take that data and format it to the destination, which will be the data warehouse. Like again, when I said when you get a good amount of data built up that you know is clean, that the numbers are right, that's when you want to implement your machine learning and start training models against good data. The better the data, the better the predictions. Now, some of the results, like I said, I actually created a working model and I used Power BI against that model just to give us some examples and to see if something like this would actually benefit our university. And you can see, um, looking at the year 2025 for over different terms, how many uh, classes were dropped or uh, how many classes were successfully enrolled and how many people had to be put on a wait list because the class filled up or whatever. You can see that for each term um, in a graph, or you can just create reports, such as the one used to see how your marketing campaigns went. This was done with Power BI. So I connected Power BI to the database and generated these reports based on the information, just bogus information I stuck in there. I think over the long run, the data analytics system, along with data analysis engineer, can save the university a lot of money, increase the number of applicants, um, more effectively target marketing campaigns, increase donations, and provide for a much better student experience. Thank you for listening, and hopefully we can get something like this implemented soon.